Hey, all my Algebra 2 trig peeps, let's do this. We are going to cover double angle formulas in this video again. Here they are, and you should have these printed out for reference because I'm not going to be displaying these during the video because we're just going to jump into using them. So finding double angles is actually not that difficult when you have the double angle formulas with you. So we're going to find the sine of 2a, the cosine of 2a, and the tangent of 2a for both of these examples. I'm going to do one, you're going to do the other, and then we'll be done. So it says the sine of a is equal to 11 over 61 when we are in quadrant 2. So, tip of the day, why don't you draw this in quadrant 2? And of course, we have our a is our reference angle. So opposite over hypotenuse will tell us that this is 11 and this is 61. So what we need to do now is use the Pythagorean theorem to find the adjacent side. Of course, that's going to be 60, but be very careful. That's where x is negative. So we have a negative 60 here. So once you have that set up, we are pretty good to go. So if we're going to find sine and cosine formulas, we are going to need to find what sine and cosine of just regular a are, not 2a. So the cosine of a, simple to do, adjacent over hypotenuse. We have the cosine of a is equal to negative 60 over 61. And of course, we were already given that the sine of a is 11 over 61. So it might help us to list the tangent. Even though we might not use it, I'm going to show you a way where you don't have to use tangent, but that would be negative 11 over 60. Okay, so the first thing we're going to do is find the sine of 2a. So the sine of 2a is given as 2 sine x cosine x. So that's just going to be 2 times 11 over 61 times negative 60 over 61. And again, if you're not working with these big crazy radical or fractions, guess what? Your calculator was going to do it all for you. So all you have to do is type 2 times 11 over 61 times negative 60 over 61 in your calculator, and it is going to give you negative 1320 over 3721. And guess what? You're done. That is sine of 2a. It was just that simple. Now let's go work with the cosine of 2a. Now you will notice that there are 3 different formulas for the cosine of 2a. Choose any one you want. It doesn't matter. I'm going to use 1 minus 2 sine squared a. Why? I don't know. I don't really have a reason for it. I'm just going to use it. So 2, and then we have sine was given as 11 over 61, so I'm just going to use 11 over 61 squared, of course. And all I'm going to do this time is type that in the calculator. I'm just going to type 1 minus and then 2 times 11 over 61 squared. That's just going to give me 3479 over 3721. Done. So now, how am I going to find the tangent of 2a if I told you we might not even need tangent? So the tangent of 2a, we can use 2 tan x over 1 minus tangent squared x and have a bunch of fractions to work with. However, I want you to go back and remember that the tangent is actually equal to the sine over cosine. So the tangent of 2a is equal to the sine of 2a over the cosine of 2a. So, since we've already found sine and cosine, we can just use that. Remember, dividing fractions is just multiplying by the reciprocal. So all we have to do is take sine, which would be negative 1320 over 3721, times the reciprocal of cosine, which is 3721 over 3479. And you'll notice these two will just cancel, and you now have the tangent of 2a is equal to negative 1320 over 3479. Done. That's it. And we're actually done with this entire problem. That's all we have to do. So if you find sine of 2a and cosine of 2a, all you have to do is sine times the reciprocal of cosine, and you will have tangent of 2a. So I did the first one for you. Now you get to pause the video, try this one on your own. After that, we should be good to go. Give it a shot. Click play when you're ready. Okay, so this one said we're in quadrant theta. So we are just going to draw our little triangle down there. Cosine is given as -3/5, so adjacent over the hypotenuse. Use the Pythagorean theorem to find out that this side is a -4 because we are down where y is negative. And as we did before, list sine and cosine and tangent. We already have cosine. If you did not use tangent, that's fine. I showed you a shortcut where you don't have to. So we do need to know that the sine of a for this problem is going to be -4/5. So using the formulas, if you use the sine of 2a, you would have had, for this particular problem, 2 times a -4/5 times a -3/5, and for sine of 2a, you should have 24/5, or 24/25. And then to use cosine, again, it does not matter which formula you chose to use. So the cosine of 2a is going to be equal to, I decided to use 2 cosine of x minus 1 this time, just because I wanted to show you that you can use multiple different options. So we have 2 times a -3/5 squared minus 1, and that's going to give us -7/25. And then for tangent of 2a, I'm going to guess that you use the shortcut method, which is absolutely fine. That would just be 24/25 times the reciprocal of cosine, which is 25 over a -7, and that would have simplified to a -24/7. And if you got all 3 of those, you are good to go. So that's it for this video on double angle formulas. This is Longo, and I'm out. See you, bye.